Hi Chem Kids, welcome to Chemical Reactions and Balancing Equations. This slide is showing you that a chemical equation has an arrow instead of an equal sign, and anything before the arrow is called the reactants, and anything after the arrow is called the products. These numbers here, like the 2 and the 2, are called coefficients, and there's an invisible 1 right here, so the ratio for this equation would be 2 to 1 to 2. Word equations is something that we're going to take after the break, so we're going to skip this slide for right now and we'll come back to it after Christmas. This slide is to tell you about these little subscripts here, the S and the G and the L and the AQ, and these are states of matter from the reactants and products. S means a solid and L is a liquid, G is a gas, and AQ means aqueous, which means dissolved in water. This is a very important slide because this is the slide that tells us that the reason that we balance equation is because we are trying to fulfill the law of conservation of matter, which means that matter cannot be created or destroyed. So the number of atoms that you have on the left-hand side have to equal the amount of atoms on the right-hand side. This slide is reminding you about the diatomic elements: hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. On the periodic table, they form a number 7. Here's nitrogen and oxygen and fluorine, and then these are the halogens: chlorine, bromine, and iodine. And then over on the left-hand side of the table, we have hydrogen all by itself. And this slide is also telling you how to balance an equation. What you basically do is you write down all the different elements that you find on one side. So in the equation, hydrogen plus oxygen makes water. You separate it into hydrogen and oxygen, and then you write down how many atoms you have on both sides. And remember, the order is metals, non-metals, hydrogen, and oxygen. M&M-HO is the preferred order that will help you balance most efficiently. Here we see that the hydrogen is okay, but the oxygen isn't, so we need to put a 2. So we add a coefficient of 2 in front of the entire H2O. And the minute you add a coefficient, take what's called an immediate recount, meaning you have to count the hydrogens again, that's 4, and the oxygens again, that's 2. So now the oxygens are balanced, but the hydrogens aren't, so we go back to the left-hand side, and we add a 2 in front of the hydrogen, making that a 4. Now we have 4 atoms of hydrogen on each side, and 2 atoms of oxygen on both sides. And what it took to get that to happen was the ratio of 2 to 1 to 2. Notice that the oxygen and the hydrogen here are diatomic. That's why they're written H2 and O2. The diatomics are the way that they are when they're alone. Notice that in water, the oxygen does not have a 2 because it doesn't have to be diatomic since it's with hydrogen. Again, the diatomics are that way when they are by themselves. When you balance equations, what happens is that bonds are broken on the reactant side and they're reformed on the product side, so that you get a new rearrangement of all the atoms and you make a brand new product with unique chemical properties on the product side. Okay, let's look at this equation. So we're going to break this equation into silver. Okay, let's try to make that silver a little better. So we're going to break this down into silver, nitrogen, oxygen, hydrogen, and sulfur. Okay, first I'm going to count the atoms on both sides, 1 and 2. Nitrogen, 1 and 1. Oxygen, 3 and 3. Hydrogen, 2 and 1. And sulfur, 1 and 1. Again, my order is M&M Ho. So I'm going to start with silver. And silver needs a 2. On the reactant side, that makes the silver a 2. That makes the nitrogen a 2. And the oxygen a 6. I don't have any more metal, so I'm going to go to my first non-metal, which is nitrogen. And the nitrogen needs to be a 2, so I'm going to put a 2 in front of the HNO3 on the product side. That makes for 2 hydrogens, 2 nitrogens, and 6 oxygens. And now I have the same number of atoms on both sides, and so the ratio is 2 to 1 to 1 to 2. The ones are coming from the fact that wherever you do not see a coefficient, that's where the 1 would be. Okay, this is a word equation which we are going to deal with after the break. That's putting the equation into words. This is another one that we're going to deal with after the break. Okay. All right, we're now going to classify reactions. There's 5 types of reactions that you need to know about. The first one is in the format A plus B going to AB, 2 pieces going into 1 piece. An example of that would be Na plus Cl2 going to NaCl. This is called a synthesis reaction, or otherwise known as a combination. The decomposition is the opposite. It's when a big clump of a compound breaks up into 2 smaller pieces, A plus B. A good example of that is 2HGO going to 2Hg plus O2. We can see that this one big piece, HGO, has broken up into Hg and O2. Notice that the O2 is diatomic because it's by itself. The next type is a single replacement reaction, and that is when you have an element by itself and a couple, and then afterward the single element has broken up the couple, so the A goes with the second element in the couple, and then it knocks off the first element. So you have someone alone and a couple at the beginning, and at the end you have an element that's alone and a couple, but it's a different element and alone and a different couple. This is the kind of reaction where you have to look at an activity series, and remember the activity series works. It's a list of elements in decreasing order of activity, and any element above the list can replace any element below the list. So in this equation, 2K plus 2HOH, which is water, goes to 2KOH plus hydrogen. We can see that potassium has eliminated hydrogen and kicked it out. That means that potassium on the activity series must be higher than hydrogen on the list. This second example I think is clearer. This is zinc with copper nitrate. Zinc is alone, copper to nitrate is the couple. Zinc is trying to bump out the copper, and if you look on the list, zinc is higher than copper on the activity series, so zinc will be able to knock out copper, and we can see that it took place because look, here's copper, which has been kicked out, and now zinc is with nitrate. Again, the activity series tells us what is possible. Here's an example of an activity series. So this is in decreasing order of activity. So for example, this is a question, will chlorine bump out the iodine? That's because chlorine and iodine are non-metals. So a metal will try to kick out another metal, and a non-metal will try to kick out another non-metal. And chlorine is more active than iodine, since on the periodic table, it's fluorine, chlorine, iodine, and bromine. Excuse me, bromine and iodine. Let me erase that. Fluorine, chlorine, bromine, and iodine. That means that chlorine is more active than iodine. Since it's above iodine on the periodic table, it will kick it out and replace it, and we can see that it's been replaced here. This next type of a reaction is called a double replacement reaction, and that's when there's two couples which switch partners and become a different set of two couples. So here we have Na and Cl, we'll call NaA and ClB, and it's reacting with silver nitrate, let's call silver C, and nitrate D. And at the end of the reaction, we have C going with B and A going with D. Again, same thing here. Two couples, HCl and NaOH, A, B, C, D, and now Na, which is C, is going with Cl, which is B. And water, this is one of those times where it's helpful to think of water as HOH. We can see that A went with D. The solubility rules are something that we will be taking after the break. These are really great, and I promise you we will see them after we come back. Okay, this is after the break too. And this is our last type of a reaction. This is a combustion reaction. In a combustion reaction, you have to have a hydrocarbon, which is some compound made of carbon and hydrogen. We're going to call it CXHY, meaning that this X and Y can be all these different kinds of numbers. But what's always true is that the reactant has to be oxygen, and the products have to be either carbon dioxide and water in a complete reaction, in a complete combustion, or carbon monoxide and water in an incomplete. So this is a complete combustion when it's carbon dioxide and water, and this is an incomplete combustion when it's carbon monoxide and H2O. Predicting products is something that we're going to be doing after the break. All right, Chem Kids, I hope that helped. If you have any questions, send me an email and work on the comprehensive review, which is really good.